Quick reminder, tomorrow, Wednesday, January 31st, we have what?
Nothing.
A group test. We will review that group test on Thursday, and on Friday we have our individual test. If you are absent for the group test, then when you return on Thursday, you will receive a blank copy of the group test to go over while we go over it. And then your individual test grade will actually count for both grades, both your group test and your individual test. Does that make sense? If you are absent the day of the individual test, be prepared to take the individual test whatever day you return. So if you are here tomorrow for the group test and you are here Thursday and then you get sick, whatever day you come back, you will be taking the individual test. Okay? Let's see, what else do I need to say? Your individual test grade will replace your group test grade if it is higher. It does not go the other way, though. If your group test grade is higher, it cannot replace your individual test grade. Okay? Just want to make sure all of that is clear. Any questions about that? Okay, let's go ahead and get started. So let's look at this inverses thing. We've done inverses before. Long time ago. Like first semester long ago. And there are 4 important steps to remember. Step 1, take out the f of x and change it to y. Seems easy enough, right? Step 2 is solve for x, get x alone. That's going to be the step that takes the most work usually. Step 3, however, is the most important step because without step 3, you're just moving stuff around. You're not actually getting an inverse. It's not an inverse until you have changed every x to a y and every y to an x. And then the last thing you do is you change the new y to f inverse of x. So? Yeah? Okay, let's try it. If this is my first equation, what does step 1 say to do? Change f of x to y. So that gives me log base 5 of x equals y. So far, so good? What does step 2 say? Solve for x. Get x alone. How do I get x alone if it's stuck with this log? I change it to exponential form. So what would the base be of exponential form? 5 to the what power? Equals, did I get x alone? Yep. So now I can go to step 3. Step 3 says what? Change every y to an x and every x to a y. So I have 5 to the x equals y. And then finally my last step says change the new y to this notation. This is what we call our inverse notation. So I'm going to say 5 to the x doesn't equal y, but it equals f inverse of x. And that's my answer. Pretty easy? Okay. Now I want you to notice something. This original problem was a logarithm. Was its inverse a logarithm? No. What's its inverse? Exponential. Okay. What if we started with an exponential? What do you think is going to happen? The inverse is going to be a log. Exponentials and logs are inverses of each other. Let me repeat that because it's important. Exponentials and logs are inverses of each other. So if I give you something like this and I say find the inverse, is the inverse going to be a log or an exponential? Exponential because this is a log. If I give you something like this, is its inverse going to be a log or an exponential? It's going to be a log because this one's exponential. So when I say find the inverse, it's always going to be the opposite form. Okay? All right, let's try this guy. This doesn't say f of x, it says g of x. Do I treat it any differently than f of x? Nope. So I'm going to change it to y. And then what am I going to do? Step 2 says what? Get x alone. How am I going to get x off of that exponent? Change it to log form. Now, for some reason, it's easier to change to log form if your exponent is on the left. If you are super confident with logs, you can go straight to log form from there. But for most people, it's easier if you write it on the left. Then I have log base what? Base 2 of what? y equals x. Is x alone? Yes. So now I can go to exponential. I'm sorry, I don't want to go to exponential, do I? I just got x by itself. So I need to move on to step 3. What's step 3? Change your y's to x's and your x's to y's. And my last step, change the new y to the new inverse notation. Now I didn't start off with f of x, I started off with g of x. So I'm not going to say f inverse, I'm going to say what? G inverse of x equals what? Log base 2 of x. Started off with an exponential, expected to get a log, everything checks out. So? Good answer. All right, let's try the next one. Find the inverse. First step is take out f of x and put in y. Well, do I have f of x in this problem? No, I have y. Okay, so step 1's done. Step 2, solve for x. Get x by itself. What do you think I should do first to get x by itself? Add 8. That gives me natural log of x plus 2 equals y plus 8. Now what? Trying to get x by itself. Someone in my last class was saying, why don't you subtract 2? Well, I can't subtract 2 because the x and the 2 are glued together by parentheses and attached to that log. So I can't do anything with the x or the 2 until I get rid of the log. And how do I get rid of the log? Go to exponential form. So what is my base for exponential form? E. What's my exponent? Equals. Is x by itself? Almost. Subtract 2. I get e to the y plus 8 minus 2 equals x. That process is kind of similar to what we had to do when we were graphing, isn't it? All right, so that was the end of step 2. I got x alone. So now what? Change your y's and x's. So e to the x plus 8 minus 2 equals y. And the last step says what? Change the y to the inverse notation, right? Well, we didn't have f of x, so I can't really use that inverse notation. So here's what I want you to do. I just want you to put y to the negative 1 equals e to the x plus 8 minus 2. That way it distinguishes that this y is the inverse of the original y equation we were given. Does that make sense? Okay. Ready for the next one? All right, what should I do first? Change k of x to y. Now what? Divide by 3y, because what am I trying to do? Get x by itself. So I'm going to divide by 3. So I have y over 3 equals 5 to the 7x. Now what? Got to get that x by itself. Go to log form. It's going to be easiest to go to log form if my exponent is on the left, so I'm going to flip it first. So I have log base what? 5 of y over 3 equals 7x. I have two options here. I can either divide by 7 like this, and I have this big fraction right here, or what else can I do? I could say that dividing by 7 is the same thing as multiplying by 1/7. Does that make sense? This is a little easier to write, I think, so I'm going to go with this one. Both are correct, though. All right, I got x by itself, so now I got to go to step 3, which is what? Change your y's to x's and x's to y's. So that gives me 1/7 log base 5 of x over 3 equals y. And the last step, change the y to the inverse notation. Now this one was k of x, so what's my inverse notation going to look like? Yep, k equals k inverse of x. So far, so good? Okay, let's try one more of these guys. All right, what do I do first? Change h of x to y. And then I'm going to do what? Add 3, because we got to start getting that x by itself. So that gives me y plus 3 equals 2 to the x plus 4. Okay, my exponent term is by itself, so what should I do next? Go to log form. It's going to be easiest to do that if my exponent's on the left. So, in log form, what's my base? Of. Now, I'm going to put the parentheses around the y plus 3 because I'm taking the log of the whole thing, not just the y, right? So I need to put parentheses there around the whole thing, equals x plus 4. X is almost by itself. I need to subtract 4. So I end up with log base 2 of y plus 3 in parentheses and then minus 4 equals x. That's what I get from there. Step 3, change your x's and y's. And then finally, change the y to the inverse notation. What's this inverse notation going to look like? Yep. H inverse of x. So? Now, I want to address this graph over here on the left for a minute. What did I say at the very beginning? If you are given something in exponential form, the inverse is going to be in what form? Log form. If you are given something in log form, its inverse will be in exponential form, right? So I want to just touch back on what the graphs of these look like. We've graphed exponentials, remember? Those had horizontal asymptotes. So you can kind of see this graph right here has a horizontal asymptote right there. This is actually the equation we just started off with. Now, I could go back to what I learned last chapter and graph these, right? Graph the log. But let's do it a different way, just so that we don't have to go through all that. A different way of doing that is we can take points from our regular graph, and how do you get the inverse points from there? Do you remember? You flip them. You make your x's y's and your y's x's. So negative 1, 5 becomes 5, negative 1. Negative 2, 1 becomes 1, negative 2. This one becomes negative 1, negative 3. Negative 2, negative 4. And negative 2.5, negative 5. Just a shortcut way to help us get to the graph sooner, because I'm not trying to necessarily review graphing here. So now let's plot these. 5, negative 1. 1, negative 2. Negative 1, negative 3. Negative 2, negative 4, and negative 2.5, negative 5. And if I draw that graph in, and that's a logarithmic graph, it has a vertical asymptote, right? It has a vertical asymptote at negative 3. So right about there. What do you notice about the graph? Need I turn it there? We have a reflection, don't we? And if you remember, if this sounds vaguely familiar at all, when we graphed inverses before, you would get a reflection across this line y equals x. So that's just kind of, you can prove that they are inverses by graphing them if you needed to, but that's why you have an exponential being the inverse of a log, and vice versa. Okay? All right, turn the page. Word problem time. Woohoo! All right, astronomy. I don't know a whole lot about astronomy, but that's okay. I think I can figure out the math problem. The difference between the apparent magnitude, also known as the brightness, and they give me a letter. That's important to note whenever they give you a letter. What is that letter representing? Apparent magnitude. Okay? So the difference between the apparent magnitude of a star and its absolute magnitude, m, there's another one, is given by this formula. M little m minus big M equals 5 log d over 10, where d is the distance of the star from the Earth, measured in parsecs. I don't know what a parsec is. You can Google it if you're really curious. Find the distance of the star Rho Oph from Earth, where Rho Oph has an apparent magnitude of 5.0 and an absolute magnitude of negative 0.4. So if they're telling me the apparent magnitude is 5.0, what letter am I plugging that in for in my equation? Little m, right? Apparent magnitude is little m, so 5.0 goes right here. The absolute magnitude is negative 0.4. What letter do I plug that in for? Big M. Now there's a minus in the equation and a negative sign. Can I put 1 to count for both?
Plus sign.
I can't put 1. You can never have it count double duty. So minus 0.4, and that's going to end up turning to a plus, isn't it? Equals 5 log. Did they give me a distance? No, they said find the distance. So I'm trying to find d. So that's the equation I have to solve. So what is a good place to start? Well, I can do 5.0 minus negative 0.4. What's that going to give me? 5.0 minus negative 0.4 gives me 5.4. Because that minus a negative becomes a plus, right? Equals 5 log d over 10. Now what do you think I can do? Divide by 5. What is 5.4 divided by 5? 1.08 is equal to log d over 10. So again, I'm trying to find d. I now have the log by itself, but the d is still stuck in the log. So how do I get it unstuck? Change it to exponential form. Just like with the other problems where I said it's easier when you have the exponent on the left, it's easiest when you have the log on the left. So I'm going to start by reversing it. And let's go to exponential form. What do I have as the base? What's my exponent? Is equal to, and how would I get d by itself then? Multiply by 10. So, when I figure this out here, when I go to my calculator, am I going to do 10 times 10 first, or 10 to the 1.08 first? 10 to the 1.08, because of PEMDAS, I have to do the exponent before the multiplication. So, 10 to the 1.08 gives me that, times 10, and I end up with 120.226. Let's just do 2 digits past the decimal, because we're actually talking about a measurement we want to understand. And what should I label my answer as? 122.2 or 120.23 what? Parsecs. Which I'm assuming is a measurement of how long something is, but I don't know it off the top of my head. But there's my answer. Any questions there? Okay. Many of the equations that you're going to be dealing with are given within the problem, like this one was. But you may encounter some like this one where we already know the equation. We have a stock that is priced at $40 and it is increasing at a rate of 8% per year. Write and evaluate a logarithmic expression for the number of years that it will take for the value of the stock to reach $50. Does this say anything about interest? No. So I'm not worrying about the PE to the RT formula. I'm not worrying about the ugly one with the R over N thing, the fraction in it. But we did know one other equation. And it looked like that if we were increasing. If we were decreasing, that was a minus, right? And that's the equation we're looking for here. So, let's start with the things we know. $40. What letter does that plug in for? P. Times 1 plus R. Do they give me R?
Yes.
What is it? 8%. So I'm going to write 0.08. Do they give me the time? No. That's what I'm looking for. So if they don't give me the time, they have to give me the Y value then. Do they? The end result that we want is $50. Now, we have solved problems like this before. I have given you ones where you're trying to find this value. I've given you ones where you're trying to find the principal or the starting amount. I think on an extra credit, I even challenged you with some where you had to find the rate, if you chose to take that. But we've never solved any where you have to find the time. The only time we've had to solve for the time, we've only been able to guess and check. Well, now with our logarithms, we can actually solve that without having to guess and check. So, the first thing I notice I can do is I can add 1 plus 0.08 and get 1.08. That makes things at least a little bit more simple. Now what do you think I should do? Is my exponent term alone? No, what should I do? Divide by 40. What's 50 divided by 40? 1.25 is equal to 1.08 to the t. How am I going to get t by itself?
Log.
Go to log form. Now I'm going to write the exponent on the left. Again, you don't have to if you're confident enough not to. And when I go to log form, what's my base? Anybody? Let me get all on the screen there. What is it? 1.08 of what? 1.25 equals t. So I've got t as soon as I can solve this. How do I solve that? You did it on last night's homework. Change of base. Log of 1.25 divided by log of 1.08. So let's see what we get. Log of 1.25 divided by log of 1.08. And I get 2.899. Let's call that 2.9 what? 2.90 is fine. I'm going to leave it as 2.9. But what should I label it as? 2.9 years. So the stock that costs $40 currently, if it progresses at the same rate it's been going, will in about 3 years almost be worth $50, is what we just found out. Okay? The last question is a very interesting question. If a 1-cent coin doubles in value every day, how many days will it take to reach a value of $3 million? It's a very interesting question, but I'm not going to address it.
What?
Because the formula that you need to use for it, I don't think is quite as easy to come up with. So that one's just kind of one to make you think, so you can think about that one. All right, so I'm going to pass out your homework. Homework is due tomorrow. We will not have time to go over the homework tomorrow, though, because we'll be taking the group test. So make sure that you are utilizing the odd answers and such that I'm posting on Google Classroom, so that way you can make sure that you're prepared for tomorrow. Okay? Happy studying!